Hello everyone, we apologize for not being here presently. Show of hands, who here has ever grown plants?
Yes? No? Great. Well, our project today is about the effects of NSK on the hippeastrum hybrids growth. I know that sounds a bit complex, but it really isn't, so let us break it down.
Our purpose was to coax or manipulate 3 hippeastrum hybrids, which are perennial herbaceous bulbous plants, with the 3 macronutrients used in fertilizers: nitrogen, sulfur, and potassium. We used chemical compounds containing those macronutrients, which were ammonium hydroxide, elemental sulfur, which was later changed to magnesium sulfate, and lastly, potassium phosphate.
These were diluted and used for our studies. For 30 days, the growth rate, height of sprouts, and additional factors were observed and were used to determine the overall growth index, the OGI. OGI is a formula that measures the scientifically perfect flower based on the measurements from this experiment.
So what is a hippeastrum? A hippeastrum hybrid is a flower that is widely known as amaryllis. Amaryllis was the original scientific name used for this plant until other flowers of the same kinship were discovered in South America in the 18th century. Amaryllis was then assigned to a group of South African plants, while hippeastrum went to a similar group from Central and South America. Amaryllis is still used as the common name for the flower, although it does not match its genus. These flowers are known for their large, star-shaped funnel-like flowers. They are known to grow 30 to 90 centimeters tall at a slow rate in an upright manner with fleshy stalks and leaves. It can grow in bright, warm colors of orange, pink, red, or white.
The genus hippeastrum includes 90 different species of flowers. They are heat-resistant and can also grow in water alone or grow in rocks. One interesting fact about this plant is that if this plant is ingested, it can produce vomiting and diarrhea.
We recommend that you don't eat it by any means.
The hippeastrum is also a cultivar or herbaceous perennial. It blooms every year and sheds of its dead leaves to the ground, while their root system and their crowns are alive, but become dormant during the winter.
The question is, how did we carry this out? Well, we set 4 pots that were completely empty, and we lined them up and numbered them. Each pot got 350 grams of soil. The soil was then moistened with very little water. 1 bulb was placed in each pot right in the middle. Then we added another 300 grams of soil around each bulb, leaving the next visible. Each pot was then seated on an aluminum container. Then the inorganic fertilizers were to be prepared. Okay, so has anybody heard of Miracle-Gro fertilizers? Well, it's a well-known fertilizer. Miracle-Gro recommends that we use 2.5 of the fertilizer to feed plants grown indoors. We did not use its fertilizer, but we did use the spoon to measure.
So we had 2.5 milliliters of ammonium hydroxide diluted into 300 milliliters of tap water for 1 plant. Then the control variable received 300 milliliters of tap water. Also, 2.5 milliliters of elemental sulfur were added into 300 milliliters of water. And finally, 2.5 milliliters of potassium phosphate were added into 300 milliliters of water for another plant. The current heights of their growth were to be recorded. The tallest leaf of each plant was to be measured starting from day 1. The flower stalk or bud would be measured from day 9 and onwards.
After recording the experiment, we recorded our results. As you can see, the graphs on the board depict the accurate heights of certain factors recorded for a time span of 30 days. If you turn to see figures 1 through 3, they depict the height of the tallest leaf of each plant. From the beginning, plant number 1's numbers were higher compared to the others. In the end, plant number 1, which was fertilized with ammonia hydroxide, grew the highest, and plant number 3 had the lowest leaf height. Then, figures 4 through 5 were also graphs that illustrate the growth of the sprouts starting from day 9 of the experiment until day 30. This factor had interesting outcomes. Figure 4 shows that plant number 1 started off in the lead, but between day 16 and day 21, the control variable grew taller and finished with the tallest sprout by a few centimeters.
Another detail was that these graphs measured only 1 sprout per plant. Therefore, there was an average taken for the plants that grew more than 1 sprout. You might also see the tables. We use a delta ratio formula, which you can see under Materials and Methods, to measure the growth rates of the flowers of the days they couldn't be measured. The delta ratio is used to measure gaps of a certain measurement. In this case, we use the formula to measure height over time to get the speed of the growth rates in centimeters over days.
Apart from our results, we also took pictures of our plants. If you look down to see the pictures, the first one on the left is plant number 3 in its first week of being planted. In general, this is an example of what most of the bulbs looked like when they were first planted. This bulb in particular shows an example of what the red blotch disease can look like, although in this case it's not this disease because it does not keep spreading deeper inside the plant.
The picture next to it is an example of what one of the plants looked like when the sprout was opening and the color of the petals were slightly showing.
The last one on the bottom is an example of one of the plants after two of the flowers fully opened and the other two on the sides were still closed. The plant held onto four flowers, each held by an inner stem. The main stem stood strong and tall with a bright, healthy green color.
After our results and research, we realized that deficiencies of NSK, especially nitrogen deficiency, can negatively affect plant growth. This was due to the plant with nitrogen having increasing growth faster than any of the four variables, so nitrogen had to be the most important element needed in the NSK ratio for hippeastrum hybrids. Our results made us realize how this experiment could be improved for future investigations. There could have been more accurate results if the soil would have been made by us from scratch with a mixture of peat moss, perlite, vermiculite, and compost to be certain that the soil was not exposed to any type of NPK compounds. In conclusion, the purpose of this experiment ended up seeing which plant would grow faster in all aspects, or which chemical would help jumpstart the growth production of the plant. As you can see, the ammonium hydroxide helped jumpstart the growth of plant number 1, and that the plant receiving sulfur might have had sulfur deficiency. Now, just quickly, if you take a look at the board, the results of the OGI formula are displayed.
If any further questions, be sure to check out our manuscript.
And yes, the onion-like thing displayed is an example of a hippeastrum bulb.
So we hope you learned something new, and next time think of what you're really feeding your plants.